these. Okay, guys, I'm going to start writing out all the right answers here. Please don't bother looking up here. Just work through yours, and they'll be there to check later, okay? I'm doing this for the few people that aren't here today, all right? I could do that. You're right. Thank you. Good ID, Nav.
If one falls right in the middle, then is the reference angle just the smaller one, like the one?
What do you mean by right in the middle?
So if it's 45 degrees, right?
It's always to the x-axis.
Yeah.
So it's still 45. Okay. Is everybody done? Or tried most of it? Everybody has tried most of it? Here's the answers. No, because the vertex is not at the origin. Yes, he's okay. No, because the terminal arm isn't on the x-axis. But he's okay. Everybody good? Any questions? Once, twice, thrice? All right. Was everybody good here? Check them, make sure you did them right, and ask me now. Because it's really, really hard to go on if you guys don't get this basic stuff. Because notice we've done we've done no trig, have we? We've only been sketching angles. We can't do the trig if you don't understand this page. That's why it's in the middle after after a little bit of notes. It sounds like the goose is in the school, but I assume it is just a trick of acoustics. But it really sounds like there's a goose in the school. I think there is a goose in the school.
God damn it, Gerald. Dude, I hope he comes back with a goose.
I can't. I hope there isn't either, because of all the disgusting things in the world, goose poo is right up there. All right, is everybody cool with these? Once, twice, thrice? Everyone understands how to find angles? Yes? Okay. Everyone's cool with these? What quadrant they're in? Quadrant 1 is 0 to 90. Quadrant 2 is 90 to 180. Quadrant 3 is 180 to 270. Quadrant 4 is 270 to 360. Everyone's good with that? Okay. Everyone's good with number 5?
Yep.
Okay. Number 6 is the really essential one to going forward with trig. Do you all understand why this is the case? Which one?
For C, for the last one, it's 330 instead of 300. Because 360 minus 30 should be.
Yeah, okay. 30. Yeah, that should be 330. Why did I write 300?
And for B, it's 300.
That's why I reversed the 2. For 150, 90. Yeah, it should be 150. Why am I doing that? 150. There we go. Now we're in business.
We can't go on. Myers doesn't get it.
No, it's because I didn't draw it. Right? I was doing it in my head. I had to make sure this is right now. No. Oh. Yeah. That's 105. It's because I didn't draw it. Just give me a sec. 180, and that's 2. No, it's not 225. It's 255. And that is 360 minus 70 is 290, 285. God. How do you avoid what I just did? Draw it. That's the whole point of this question. Draw it. Just give me a sec now. When you are in doubt in trig, draw it. So you don't do stupid crap like this. Understand? Draw it out. If you are too lazy to draw it out, like I was, and you are in a rush, do not do addition and subtraction in your head. What should you use? Your calculator. Or you will end up looking stupid in front of 30 people like I just did. Of course I'm recording it, but you guys don't watch it. Nobody watches these, so it doesn't matter. I can say anything I want on here. Nobody watches them. Right?
The FBI is always watching.
Yeah, the FBI cares about my trig lessons. Do not do what I just did. Draw it or actually use your calculator. Don't be a doofus.
The only way to send encrypted messages is to send it
Huh?
to videos.
45, 35. B is 120. Yeah. See, I got one wrong on every one because I didn't draw it. Don't be that guy. Now I got to double check because I didn't draw these either. I got to make sure they're right. Quadrant 4, 288. Yeah, that's good. Quadrant 2. Up there. Minus 56. That's good. Quadrant 3. Down there. 18, 198. That's good. Quadrant 4. Down there. 3. That's good. This is the type of thing that you guys would give me on a test. You would do all these wrong, and then you would do all these right. Or you would do all these right and do half of these wrong. And then I would not know how to help you. Because you would prove that you know what you're doing, but on the very question right before you would show that you had no idea what you were doing. And then I wouldn't know how to fix it. All right, so is everyone good? Yeah? All right, we move along. Yes, we do, because it's only 8:55, Joel. We are not stopping.
Dang it.
The clock's pretty close to right. Good. Okay. You just have to sketch what I'm about to do. You do not have to actually make it happen. Darn it! It was going so well. Pretend my eraser's working. Sketch a circle. Oh, God, that's hideous. That'll do, pig.
Okay.
All right.
Blue.
Circle, yes? Everybody with me? You've all sketched a circle. Kelvin is being Kelvin.
He's not using his measurement.
Damn it. Screw you, stupid. All right. Circle. Yeah? Okay. What measurement can you give to that black line that we have just drawn onto it? Can you give it a measurement right now? You could give me a number for that right now?
I could technically say that I would.
If you look at the title of this section, you might be able to deduce that distance. But if you can't deduce that, can you give me a number there? No, because I've given you no numbers, correct? But since it goes from the center of the circle out to the edge, what can we call it? A radius, right? So that is an R, a radius. Does everyone agree? And how many radii could I draw in this circle? Infinite amount, yes? We're going to draw 4, 1 in each quadrant. And all of those share what characteristic? They are all radii, which means what is their measurement? All going to be the same. Is everybody cool? All right. So these guys are all R. Please notice that my pen has stopped working. These are all R. Please notice that I've written the R very close to the center. There's a reason for that, yes? Okay. Now, do we have anything we can do trig with yet? No. To do trig, up until this year, you guys have needed a triangle, correct? So let's make those triangles. I'm going to use different colors. You don't have to. I'm going to use this. And I'm going to use green down here. Now, how would you measure this distance right now? What measurement is that? It's x, isn't it? Why, Kelvin? Because it's on the x-axis,
Y, Calvin.
right? And you don't know how far it is. So it's x. Agreed? What is this distance? Y. Is everybody cool? Okay. Do that for the other 4 triangles. What is this distance? What is this distance? No. Negative x. What is this distance? Positive y. We've already done this distance is negative x. What's this distance? Negative y. And then down here, we've already done this as positive x. What's this? Negative y. Is everybody cool with that? All right. Now that I have made this triangle, R can have a new name, can't it? It is H for hypotenuse, isn't it? Is everybody cool with that? Everybody? Okay, now, if I were to ask you to tell me, just using this triangle, what is sine theta? Sine is opposite over hypotenuse. So what is sine theta here? Y over x? H. Everybody cool? Everybody agree? This y, because that's what's opposite. Agreed? Over h. Is everyone cool? Okay. What's cos? X over h. Agreed? And what's tan? Is everybody cool with that? Yes? Everyone is good? Okay. That was in quadrant 1. What happens in quadrant 2? What is sine? It's y over h, isn't it? What is cos in quadrant 2? Negative x over h. What is tan in quadrant 2? Y over negative x. Interesting. What happens in quadrant 3? Negative y over h. Negative x over h, and this is tricky, y over x. Why, Kelvin? Because they're both negatives. Everyone see that? And what happens in quadrant 4? Negative y over h. x over h, negative y over x. And all of you should notice something there. What do you notice in quadrant 1? They are all positive. So in quadrant 1, where x is positive and y is positive, all sine, cosine, tan are all positive. What happened in quadrant 2? X is negative, y is positive. So what is the only thing in quadrant 2 that's positive? Sine. What about quadrant 3? X is negative, y is negative, so only tan. And over here, x is positive, y is negative, so it's only cos. And that sets up a nice little mnemonic device for us. C-A-S-T. Cast. Coses are always positive here. Everything's positive there. Sine's there. Tan's there. Now let me ask you a question. I only wrote x's and y's, yes? What did I not write here? The hypotenuse. Why, Joel? The x's and y's will tell me what quadrant I'm in, yes? And that will tell me what is positive and what is negative, yes? But I don't need the h's because h's are always positive. Why? Somewhere down at the bottom of your sheet. H is always positive. Why? How do you find the hypotenuse? Say what you're actually thinking, Kelvin. X squared plus y squared square root, yes? Soon as you square anything, what is it? Positive. Everybody understand? So it is always going to be positive. Now this sets up something new for us, doesn't it? It sets up cast, but it also sets up this. O over h is y over h. A over h is x over h. And tan, O over a is y over x. Where else do we see x's and y's? As a point on the coordinate grid. Everybody cool with that? Okay, turn your page over and let's actually put that into use. You should be on 154 now. Given the following points, find the value of all three. Well, we know that sine equals y over h. We know that cos equals x over h. And we know that tan equals y over x, yes? What do I have right there? An x and a y, don't I? What am I missing? H. Well, we know that h is the square root of x squared plus y squared, yeah? What's x squared? 16 plus y squared. So this is the square root of 16, yes? So what is our h? 4. Agreed? Okay, so now what are my sine, cos, and tan? Sine of this angle is what? 0 over 4. Agreed? What's my cos? 4 over 4, which is 1. And what's my tan? Y over x, 0 over 4. Is everybody cool? Everyone's good? Okay, so what's b? The 0 makes it really easy. There's a reason that I've got the 0 there.
Well, I'm just thinking about the length of the line.
What's my h? 3. So what are my 3? Sine, cos, and tan. Sine is 1, cos is 0, and tan is undefined. What about this one? What's my h? 5. So my sine zero, my cos, look again, -1, and my tan, zero, because it's y over x. My h here is 2. What's my sine? Look again. -1. What's my cos? 0. What's my tan? Undefined. Everybody cool? Now, all you got to do is think about it. 4, 0. That angle is 0, isn't it? So of course it has no sine. Of course it has no tan. But its cos is 1. And if you go to your calculator and do cos 0, you'll get 1. Now, everybody's cool with this, yes? All right. Now let's actually do something with it. 4, -4, 11. What's that -4? X. What's that 11? Y. So how do I find sine, cos, and tan? What is sine? Y over h. Do I have a y? Yep. Do I have an h? Nope. What is my h? H equals the square root of what? -4 squared plus 11 squared, which is what? 137 equals the square root of 137. In trig, we leave it that way. So now, what is sine? 11 over root 137. Right? What's cos? -4 over root 137. What is tan? 11 over -4. I also want the angle. Here's where it gets weird. How do I use those and my calculator to find an angle? Second function, right? Which one of those three are you going to use? Which one, Joel? Tan, because there's no roots in it, right? So everybody get out your calculator and tell me what theta is. Shift, tan, 11 divided by -4. Right? Everyone agrees? You can see it on my screen. What's the answer? -70. Now, stop for a moment and think about this. -70. I don't know what to do now. So what did I tell you to do if you don't know what to do? Draw it. Where is -411? Negative 4, up 11, correct? Everyone agree? Everyone agrees? Okay. This is negative 4. This is 11. This is root 137. Where is the only place in this structure that could be 70? Can it be this? No. Why? Because that goes past 9. Right? So where must that 70 be? The reference angle, right here. There is my 70. But why is it negative 70? What direction did I go from my reference angle? Which is clockwise, right? Which is negative. So this is my reference angle. Now here's the problem. Is that my theta? No, because where do we start counting theta from? From 0. Here is theta. So how big is theta? 110. Does everybody get it? Pardon me? Negative 70 is not theta. It's the reference. Can you? That's the next question I'm about to ask you. It does. Why, Joel? What'd you say? What'd you say? Why did I ask you what one of them you were going to use? Because all of you would probably have said 11 over 4, yes? 11 over negative 4, which would, all of you would get negative 70. Then you needed to see that. Now, if you go to your calculator and you check one of the others, shift, sine, 11 divided by root 137. Oops. Delete. I don't know how to make my calculator do what I want it to do right now. 137. What happened if I use sine? I get positive 70. Why did I get positive 70 if I use sine? Why would it give me positive 70, do you think? Because I'll let you all know, when you do cos, you get the right one. Okay? If I do shift cos negative 4 divided by root 137, I get the right one. Why does sine screw me over this way?
Because the 11 is the y.
Because it's not adjacent.
I'm sorry, Joel, because the 11 is the y. Okay. So where in this drawing is 70? No. 70 in quadrant 1, isn't it? Right? So I'm going to erase all this. Except my eraser's not. There we go. Here is 70, yes? Everybody with me? Just 70. Right? So that's root 137, and that's still 11, isn't it? Right? Your calculator does not know what quadrant you are seeking, does it? And CAST, right? sine would be positive in quadrant 1, wouldn't it? So your calculator doesn't know you need quadrant 2. Your calculator tries to do everything in quadrant 1. So when it gives you 70, this is what your calculator thinks you want for 11 and root 137. You have to use your brain to understand that we are over in this quadrant, because the 11 is the same in both. Now, why did it say 110 for cos? Because you used a negative. So then it knew, oh, I'm on this side over here. Is everybody with me? Cool? You still have to know what you're doing for your calculator. It is not doing the math for you. It's doing the arithmetic for you. Do you understand the difference? All right, you guys try the next one. And then we're going to stop, and I'm not even going to give you any homework. I'm going to finish your test tomorrow. Which I lied, we're not going to stop. But I'm not going to give you any homework because you got a test tomorrow. So there's my x, there's my y. Sketch and determine the value of the angle whose terminal arm passes through there. Now, since I have x and y, do I even need to find the hypotenuse? No, because I can just do tan, can't I? Tan theta is negative 3/4, yes? And I know that I have to be out here in quadrant 4, correct? So when I do this with my calculator, what do I get? What does theta equal? Negative 37. So this in here is 37, right? So how big is theta? What does theta equal? 360 minus 37 to get 323. Is everybody cool?
Wait, it's not minus. It wouldn't be minus.
No. No. Because again, your calculator is doing this work and it is giving you the reference angle.
Oh, so switch it down.
All right. Is everybody cool with that? Everyone is good? Okay. Turn the page over. What do we know about this angle? We know it's tan, and we know it's in quadrant 2, yes? Where is quadrant 2? Right here, correct? I know that tan is y over x, yes? So I have to have either a positive y and a negative x, or a negative x and or a negative y and a positive x, yes? But since I'm in quadrant 2, it must be going out here, right? So that makes my x what? Negative. Negative 5. And what's my y? Positive 9. I want to know the value of this. So, since I have tan, what can I do? What will get me an angle? Shift tan. So if I do shift tan of negative 9 divided by negative 5, what do I get? What do I get? 61 degrees, right? Where is the 61? It's the reference angle. So what's theta? What does theta equal? 180 minus 61 to get 119. Is everybody cool? Yeah? Okay. This is all calculator work, right? What's the sine of 43? Just hit it on your calculator. Sine 43, what is it? 0.6820. What's 170? Great. What's positive 350? 350. 0.9848. Wait a minute. What's tan of 10?
0.1763.
1763. What's 223?
6819.2.
So 0.6820. What's 317?
0.6819 negative.
0.6820. What's tan 270? Undefined. What's tan 190? What are you seeing? There is a pattern. What letters have the same answers? The exact same answers. E and F. Yep, we'll come to D and H in a minute. Why do E and F have the same answers? Where is, yes, not quite the same quadrant. Where is 223? Right here, yes? There's E. Where's F? Fourth quadrant. There's F. What's the same in both of these, Kelvin? Reference angle is the same. Isn't it? Because that's 180 plus 43, and this is 360 minus 43. Does everybody see this? That's why this is happening. Everybody cool? Now, who's got negative values? B and C, right? Why? Where's B? Where is 170? Quadrant 3, right there, right? Where's C? 350, right there, right? What's the same? Reference angle, that's 10. That's 10, isn't it? This is C. C-A-S-T. So he had to be positive. Right? This is B. C-A-S-T. He has to be in a negative spot for cosine, doesn't he? That's why that happened. Is everybody cool? Yes? 100% cool? All right. You have not due till Wednesday, number 6 and number 7 on page 156. Everybody cool? Tomorrow, you're writing your test. Wednesday, we are going to do page 96 and 97, which in your books is 156 or 157 and 158. We're going to do that in class Wednesday. And then over your 4-day weekend, I'm giving you an assignment.
You have a 4-day weekend again?
Yes, you guys have Thursday, Friday, Saturday, Sunday off. By the way, no stress, but Wednesday is the last day you will see me. And that's all I'm going to say. No, the last day you will see me while I am still only 41.
You got my hopes up there for a second.
This is where I stop the recording so I can make a joke back to you.
I don't get paid